All right, so let's learn about function notation. So if you have a function, then every time you plug in an x, you get out a unique y. And what we do is we say if f is the function, we write f of x and we say y is equal to f of x. This is called function notation. Okay. F of x is called the value, y is the y value, and we graph it by graphing the points x comma y or x comma f of x. So for example, if y is 2x minus 5, we can also write f of x as 2x minus 5. This just makes it clear that we have a function, and it tells me if I plug in 1, if I let x equal 1, then I get out y is equal to minus 3. But what if I let x equal 3? So go ahead and plug x equals 3 in here, then you get out y is equal to 1, and that's why we would write over here f of 3 equals 1. If you plug in 3, you get out 1. Okay. A lot of people like to visualize this as a little machine. You plug in an x, the function f does something to it, and then it outputs f of x some other number. Okay. The restrictions are you can only plug in things from the domain. Remember, that's what the domain of a function is, stuff you're allowed to plug in. And every time you plug something in, you get out exactly one output. You can't get out multiple things for one input. It is okay to get out the same output for different inputs. That's fine. What you can't do is get out multiple outputs for the same input. Okay. So if we're writing y is equal to f of x is called the independent variable. It's independent because you can let it be whatever you want as long as it's in the domain. Y is called the dependent variable because it depends on x. When you make a choice of x, it will tell you, the function f will tell you the value of y. So y is said to depend on x. X is independent and y is dependent. Some people also call x, the independent variable, the argument of the function. It's less common. All right, so suppose I have a function. F of x is 2x squared minus 5x, given right up here. Can you evaluate f of 2? Can you evaluate f of x plus f of 2, 2f of x, f of negative x, negative f of x, f of 2x, f of x plus 2, and f of x plus h, where h is just some other letter? Okay, so I would actually suggest pausing here and doing all 8 of these. Okay, can you write out what is f of 2, what is f of x plus f of 2, what is 2f of x, and so forth? And then we'll go through the solutions and simplify them. So please pause here and check. Okay, so let's go through the solutions. So for the first, all we have to do is substitute 2 in. If you plug in 2 for x, you're just replacing everywhere there's an x, put a 2. 2 times 2 squared minus 5 times 2. 2 times 4 minus 10, or negative 2. So what's f of 2? It's negative 2. Next, what's f of x plus f of 2? F of x was given as 2x squared minus 5x, and we just computed that f of 2 is negative 2. F of x plus f of 2 is just 2x squared minus 5x minus 2. Great. What about 2 times f of x? F of x is 2x squared minus 5x, so 2 times it is just 2 times 2x squared minus 5x, which distributes as 4x squared minus 10x. Next, what about f of negative x? This is very similar to the first one of what is f of 2. Everywhere you see an x, put in a negative x, and then simplify. So remember, f of x was 2x squared minus 5x. So I'm replacing all of my x's with negative x's. 2 times negative x squared minus 5 times negative x. Notice that negative x squared is the same thing as x squared. So this doesn't really change much. But negative 5 times negative x simplifies to just plus 5x. So once we simplify, f of negative x is 2x squared plus 5x. What about negative f of x? This is now similar to 2 times f of x. You're just taking f of x, 2x squared minus 5x, and sticking a minus sign in front of it and then distributing. So you end up with negative 2x squared plus 5x. Notice that this is not the same thing as f of negative x, which we computed up here. Okay? So f of negative x and negative f of x are not the same thing. They might be for certain functions, but in general, they are not the same thing. Okay. Continuing, what's f of 2x? Well, I substitute in 2x wherever I saw an x. What's 2x squared? It's 4x squared. Okay, remember that I'm plugging in 2x, and using parentheses is very helpful. If you didn't use parentheses, you might just write this and think that this was a 4x squared, but it's not, okay? With parentheses here I get a 4x squared, which when I then multiply by 2 gives me an 8x squared. Parentheses are your friends. Use them judiciously. Okay. Then minus 5 times 2x, which is a minus 10x. Okay, so I'm just going to clear off the 10 marks. Okay. So notice this is not the same thing as we got on the previous slide when we did 2 f of x. F of 2x and 2f of x could be very different from one another. What's f of x plus 2? Well, I plug in an x plus 2 using parentheses appropriately. I'm finger wagging at you. So many people don't use parentheses when they save you so many mistakes. When you're plugging in x plus 2, do it with parentheses, because this now has to be distributed, and this also needs to be distributed. If all you did was write this, you'd get totally the wrong thing. Okay. But if we do expand all that out, we square the x plus 2, then I distribute the 2, and simplify. 2x squared plus 3x minus 2. Notice that this is not f of x plus f of 2, which we did on the first page. Sorry, I didn't write that very clearly. This is not f of x plus f of 2. This and this could be totally different from one another. You can't just distribute the f. It looks like multiplication, but it's not. This is function notation. This is f of x plus 2. It is not f times x plus 2. It does not distribute. Okay, function notation doesn't necessarily distribute like this. You also can't just factor stuff out willy-nilly. Okay, function notation is not the same thing as multiplication, so you can't use the same tricks. Okay. And finally, what about f of x plus h? Well, first of all, this is definitely not going to be f of x plus f of h. We already know it doesn't just like that. So we have to actually go ahead and square x plus h and then distribute the 5 here. So there is distributing the 5 and squaring the x plus h, distributing the 2, and simplifying. Okay. And again, just to repeat, I pointed this out as we went along. F of x plus 2 is not f of x plus f of 2. F of negative x is not necessarily negative f of x. 2f of x is not necessarily f of 2x. You have to just do the computation and see what happens. It's not so straightforward. Okay. So let's go ahead and do this example as well. Verify the following. Okay. This is just how to use a calculator to find values of a function. Well, what's f of 5.678? Just square it. And if you're using a calculator, you should get 32.23 blah, blah, blah. For my purposes, by the way, I would never bother writing more than 2 decimal points. I would have just written this as 32.24, and this would have just been 5.68. But whatever. What about f of 1 of, if f of x is 1 over x? F of 5.678 is 1 over that, which a calculator will give you the following answer. Whatever calculator you're using, just make sure you know how to use it. Okay, and what about root x? Again, you should be able to compute things. Okay, so I'll stop this video here, and then we'll come back with implicit form of a function.